the topic, that is displacement time graph. So displacement time graph, here you can see that this is a displacement time graph, and displacement is the shortest distance between the initial and the final point. So displacement time graphs is how much the body has displaced in a given time. So here you can see that the body has displaced 10 meters in 6 seconds. So we can get the velocity as well, as velocity is equals to displacement upon time. We can get the velocity that would be none other than 10 upon 6, which would give us 5 by 3 and approximately 1.66 meters per second. So friends, this is how easy physics is, and there is no need to worry about this subject in IGCSEs, as if you just put in a little bit of effort, you can easily understand all the concepts, and this is a subject of mostly understanding the concept. So friends, one more thing. The speed of the graph can also be the gradient, that is change in y-axis upon change in x-axis. So plotting graphs, I'm sure all of you must have learned earlier this year. So at x we have 6 and at y we have 10. Okay, so 6 and 10, and here both of them are 0, 0. So what we'll have is that change in y-axis, which is the displacement axis, upon the change in the time axis, x-axis, which is the time axis. So we'll have the formula, friends, is y2 minus y1 upon x2 minus x1, x2 minus x1. Friends, so this is the basic formula, and take here in this line, which is from 0 to 6 or 0 to 10, uh, at any point which you take, whether you take this point or whether you take this point, any point which you take, I can guarantee you that the speed which you will find is 10 will be 1.66 meters per second, as here we have constant velocity. And constant velocity, friends, is velocity when we are moving in the same direction with respect, and equal amount of displacement is happening in equal time interval. So this is the basic thing about constant velocity, and here you can see that by displacement time graph you won't get the speed, you will get the velocity of the object. But if the, and you can also get the speed, as here if the displacement and distance are same and the body is traveling in a straight line, because if it is traveling in a straight line, then and in a same direction, then displacement and distance, they both become the same. So this is the formula, please go through it, and here you can see it is 1.67 meters per second. So I hope you understood this concept as well. And friends, from here to here, we have constant velocity, that or uniform motion, because equal distance is being covered in equal time intervals. Whether you take this point, whether you take this point, so equal amount of displacement is happening in equal time intervals. Now from here to here, the thing is the time is increasing, but there is no displacement, so body is not moving. That tells us that we have a zero displacement from this place to this place, meaning that none other than the fact that the body has zero velocity, and the body is at rest, correct? So body is at rest as there is no displacement. So what we'll get is 0 upon time. That is 6 to 12, which is 6 seconds. But as we know, 0 upon anything would give us 0. So friends, displacement, if it is 0, the velocity which we get is also 0. So the body is at rest here. And in this path, the body is moving. The body is moving, and it is in and it has non-uniform velocity. Why does it has non-uniform velocity? Because it is not covering equal displacement in equal time intervals, as there are a lot of curves along it. You can see these curves. So there is no straight line which is suggesting the fact that there is equal amount of velocity happening at different time intervals. So this is it for the displacement time graph. And coming to the last topic, friends, that which is speed time graph. Speed time graph is can give us change in velocity upon change in time, as it shows us the speed at two given intervals. See, so here, and there's one more fact. These are like the eighth wonder of the world, as if you calculate the area which is present in the VT graph, which is the velocity time graph, or you calculate the area in the speed time graph, what you would always get is none other than the distance or displacement covered. You can see the shaded portion here. This portion is none other than the distance that is covered. So if you multiply it by the amount of time taken by the speed which the body has, see at last, which actually is none other than a derivation of the formula speed is equals to distance upon time. So speed into time would give us the distance. So friends, here you can see the time at this interval. We are multiplying it by the speed which is at that given interval, and there we would get the distance. Along with that, applying the formula of the right angle triangle, we can also get the entire average speed. Average speed is the total distance covered upon total time taken. So friends, gradient of this graph would give us acceleration, and the area covered by this graph would give us the total distance covered. So it go just telling you the basic things. A speed time graph plots speed against time. Distance traveled can be calculated via the area underneath the graph. Acceleration can also be calculated by calculating the gradient on the graph, that is y2 minus y1 upon x2 minus x1. Friends, this is such an easy concept, and I hope all of you had fun. Though I'm a bit boring teacher, but I can guarantee you that when you get these answers correct in your examinations or practice paper, the amount of satisfaction which you get is irreplaceable. Now, moving further, I want to tell you that there are a few, what do we say? There are a few graphs, and we'll just understand them. So car accelerating until it reaches maximum speed. So here you can see that it starts with a curve showing us that the speed is increasing. But as the curve starts to the speed time graph, it forms a straight line. We can see understand the fact that time is increasing and the body is not at rest, but the body is traveling with the same speed in the given time. Are you understanding? In distance time graph, it was at rest, but in speed time graph, it is continuously moving with that same speed. And here we can see that it is the maximum speed. Here this point is the maximum speed achieved by the object. Moving further, here in this diagram, we can see that with respect to time, please understand my words carefully. With respect to time, the body speed is increasing. So we will have a positive acceleration, right? And here the body will have a constant speed as the speed is not changing over time, and the body is continuing to move with the same speed. But moving further here, you can see that its speed is decreasing over the time. So our u, which is the initial velocity here, is greater than any point on the downward graph. So what we'll get is negative acceleration, which is a deceleration or deacceleration. Fine. I hope you all understood the concept. And here we can see that a skydiver, from the time she jumps until the moment she reaches the ground. So she jumps and her speed increases. She jumps and her speed starts to increase. And slowly, when she reaches the maximum velocity, uh, she opens up the parachute. The acceleration becomes negative, denoting the deacceleration. Finally, the speed starts to drop down and she reaches the, what do we say, terminal. No, she reaches a constant speed. As she opens the parachute, the gravity and air resistance, they quickly start to get becoming friends and they quickly become equal. So this is everything about the speed time graphs, and I am happy that you watched the entire video. Hopefully most of you won't, I know that, and I hope that you all get to learn from it and do well in your exams, in your practice papers, and everything you do. And friends, wait, there's one more thing. Yes. Um, always remember that at any instance, never lose your focus in physics or in mathematics or in any subject, basically in anything which you do, because focus is most important and it will help you to achieve great things. Bye for now, and keep working hard, and thank you. Bye.